So I thought it would be helpful to work some of the more difficult problems in the chain rule and just kind of tape it and we'll work it together in class. So this is the one I left you with the other day and I wanted to kind of go through on how I would attack this. So the main thing is to look at the big picture and see what the framework of the problem is. And what I notice is this is tangent of something. So if I just kind of cover the inside up, I can see that this basically fits the formula tangent of u. And so I'm going to replace the inside with u for now, okay? And then I'm just going to take the derivative of this, and so I have like a template for my answer. And then I'll go in and fill everything. So again, I look at the big picture. Big picture is this is tangent of something. So I rewrote it like this. And then I'll take the derivative. So this was the problem we left you with at the end of the last lesson. A little bit of a glare there. So I know the derivative of tangent is what? Yeah. Secant squared of u, which is the inside. But the inside is a function of x. Sorry. The inside is a function of x, so I got to multiply by. Yeah, but in this case, it's u, so I multiply by u prime. So now, that's my answer. Now the only problem is I got to figure out what u and u prime are. So this is one way I work it to kind of help make the work a little neater. So now if I just go to the side, okay, well what did I call u? I said u was equal to what? Sine of 4x, right? And so then if I want to find u prime, that means I got to take the derivative of sine of 4x, which here's another chain rule because of the 4x inside of the sine. So it helps me when I have a nested problem like this. So, all right, so the derivative of sine of something is what? Cosine of 4x, but since this, it technically is the inside, I got to do chain rule again, so I'm going to multiply by 4. So 4 cosine 4x. So now, sine of 4x goes in here, 4 cosine 4x goes out there, and that's it. So you get secant squared of sine of 4x times u prime, which is 4 cosine of 4x. And what I would probably just do is move this 4 to the front, 4 secant squared sine of 4x times cosine of 4x. And that is the derivative of the problem that we left you with the other day.
It's blowing, come right here, it's blowing heat mode. Coach, is your heat on?
I don't feel it. I just think nothing's on.
No.
Okay. All right, does that help there a little bit? So I look at so it's important to find the big picture on the problems, okay? So I'm trying to figure out what's the overall way that I'm going to differentiate. And sometimes it's kind of like two problems in one. So now what I've done, I've given you 3 problems over here. Sorry, there's a little bit of glare on the, there's a little bit of a glare on that. Okay. All right, so we'll go to this first problem here. What's the first thing that you see on number 1? When we're going to go to attack this, what's the overall big picture? Like, what do you think is the big rule that we're, like the main rule that we're going to use? So on this one, it was tangent of something, so I know I need a tangent. On this one, what's the biggest thing that stands out to you?
Multiplication.
The multiplication. This is a product rule. So right now, I've got to go and kind of look at this as a product rule. And I'm probably, since I use u for the inside, I'm probably going to just use f and g for my product rule. So I'm going to call that f and I'm going to call that g. So the first thing we got to figure out is that this is a product rule. It's x squared as a function, square root of x squared minus 4 is a function. So the first thing I would do is write out my product rule, and I would call this f and g. And then because then I'll probably need a u maybe when I go and I'll do this. All right. But you do have a rule for square root of u. So maybe attack that one with product rule and we'll look at that. Okay. See how your work is organized and see how that goes. One thing I did notice on some of their answers, they do leave negative exponents. I noticed that in WebAssign. I don't do that, but I saw some answers, they leave negative exponents, so just be aware. Okay. So we decided that this was a product rule. We've labeled what our F and our G are. I could have called U and V, but I might call the inside of that square root U. So to get the derivative of F, does it require a chain rule? No, it's just a regular old derivative of x squared is what? 2x, so that's done. Now this is technically square root of u, because the inside is a function of x, and we wrote out a rule for square root of u. So the derivative of square root of u is what? 1 over 2 square root of u times u prime because of the power rule. So you can see how it's kind of a substitution inside of a substitution. So real quick, I can see that this is my u right here, so my u prime is 2x. Okay, so when I put the derivative here, so g prime is going to be 1 over 2 square root of x squared minus 4 times u prime, which is 2x, because that's the derivative of the inside. These two should have canceled. Okay, and then now you plug everything in. All right, so let's see. So we get f prime, which is 2x, g, square root of x squared minus 4, plus g prime, x over square root of x squared minus 4, times f, which is x squared. Okay. Now, the next thing that we could do, if we wanted, so again, this is just taking in another step. I could probably say this x times x squared is what? Make that x cubed, right? So we could do that. The other thing is, if I get a common denominator, it now takes the radical out of this numerator here. So the other idea is, you go ahead and get your common denominator of square root of x squared minus 4, and when you do that, you'll see that this over here, we will lose the square root. So this right here, those two square roots multiplied, we lose the radical, it just becomes x squared minus 4, and then I have this 2x in front, and I could distribute that. So this is some algebra we could do, but technically this is the derivative. If I do the algebra, let's see, we get 2x cubed minus 8x plus x cubed all over the square root of x squared minus 4. And so we get 3x cubed minus 8x over square root of x squared minus 4. So you can see that this version of the answer is much more simplified than that. And again, all I did is I got a common denominator of square root of x squared minus 4, which I lose that radical, and I go from there. So either of these in the circle are correct. And you can see that this was a product rule, and then as I set up my product rule, I had to do a chain rule over there. So the big thing I want everybody to understand is, even though I've been doing this a long time, it would not change how I worked the problem. I would have worked the problem exactly this way. What I mean is, I give things a symbol, and I write the formula for the answer. So I said, okay, it's product rule. I call that F, I call that G. I write my product rule out. And then it makes it clear what I have to find and what I have to sub in. Because when I had to go find G required a little work to get G prime. Okay? So notice that the work is organized, and I use F, G, U's, and B's to do my label. All right, that's my biggest hint to you. But then this is on video, so you can rewind it, play it again, look at it, and we'll move on to the next one. You got good? Okay. So, next problem, number 2. So, the question is, again, how do I approach this? Because what you're seeing on all of these, we have composite functions. We have functions inside of functions, okay? So, and I don't really have to have this parentheses in here because we know it's cosine of 4x. That 4x is in the cosine, so it's a lot to put there. So I don't really have to have those parentheses. It could just be written like this also. But the question is, can you look at it and get the big picture? Say, all right, overall, this is a what problem? Like this one, you could see the big picture is this is a product rule, then we narrow our focus. Don't look here. A lot of us my eyes are going there, but that's on the inside. Okay, that's going to be part of the problem, but that's not the main differentiation rule. What my eyes go to is this. My eyes go to that, okay? The big picture. So the question is, on the big picture, what type of problem is this? On the big picture, what type of problem is this? That's the main question, okay? So how would you approach this if this was your, the big picture? What would you do?
Power rule.
It's power rule. Okay, so that's exactly right. So if it's power rule, then I'm going to call the inside of this what? What would you maybe want to call this? What's it? U. Okay. So again, I'll make a template and just say that this is u to the 5th, not cosine of 4x to the 5th. It's u to the 5th. Okay. So again, now once I get the overarching theme, what it is, then I'm going to go and do the derivative. So let's see. All right, so now I'll make a little template for my answer. So, all right, now what should be the derivative of u to the 5th? So just do u to the 5th. So again, I've made a template of what it is. Now I'm going to write a formula for my derivative. So, but remember, u is not u. U is just not a letter. It stands for this whole function, okay? So what would be the derivative of u to the 5th? 5u to the 4th times u prime. You gotta do power rule. I mean, you gotta do, not power rule, it is power rule, but you gotta do what? What rule? Chain rule, okay? If you're not multiplying by u prime at the end, by the derivative of the inside, then it's gonna throw it off there. Okay, so now now this is my answer. So now I just gotta go to the side and figure out, well, what's my u and what's my u prime? So I go to the side, u is cosine of 4x. So what's the derivative of cosine of 4x? So again, now we have another chain rule, right? So now I gotta find u prime so I can sub in. Well, the derivative of cosine is what? Negative sine of 4x, but I gotta multiply by what? By 4. So I would make it negative 4 sine 4x. Okay. So now if I sub in 5u is cosine of 4x to the 4th times u prime is negative 4 sine of 4x. Okay. So I sub those in, and then the last thing I would bring this negative 4 to the front, which is negative 20 cosine of 4x to the 4th times sine of 4x. There's the answer. And again, it's on video, so you can go back through and look at the steps. So I have to decide what's the big picture. And the big picture on this one is exactly right. It's a power rule. But the problem is on the inside, I have a trig that I have to use chain rule on. So this is why I was saying my warning to everybody that this now is the next level. You went from iPhone 2 to iPhone 11 just like that. Okay? Not in terms of what it's capable of, I guess. In terms of what we're able to differentiate now. All right? So 3, what is similar about number 2 and number 3? Because there is a similarity there. 2 and 3 are similar. They're both power rules. Again, your eyes need to go to the big framework, not to the inside framework. So the big framework is it's something to the 7th. So what I typically do is I say, okay, so we've got this stuff here. Let's erase this. Again, it's on video, so you can always go back and pause and rewind and all that. So 2 is done. So we go to number 3. 3 is also a power rule. Okay, and why is it a power rule? Because it's something to the 7th power. That's why it's a power rule. All right, now, so we'll write this over here. Now, I'm going to replace all of that in there with what? What could we call that on the inside? U. But now when I have to go and take the derivative of that, I may call that t cubed something, and the t, I probably won't use u and v again. I may use f and g for my quotient rule. So I'm going to take this out and write this as u to the 7th. And I go to the side and say, okay, my u is the inside there, t cubed over t to the 5th minus 1. All right. So I still have not done any differentiation. All I've done is just organized it and said, okay, I'm recognizing that this is a function, in this case, a function of t to the 7th. So I know it's power rule. So this is a power rule. Okay. So on my steps, what is it I've done? So I've replaced with u's or f's or whatever to make a formula. Then what's the next step that I've been doing on each problem? Once I got this little formula here for what y is, what do I do next? So Graham, what's been my next step? Every time after I've kind of rewritten it like this, then what have I done?
Oh, you differentiate.
I differentiate, that's exactly right. So after I rewrite it with a substitution here, then I go and differentiate, so I have a formula for my answer. So now it's just, well, what's the derivative of u to the 7th? So Ivan, what's the derivative of u to the 7th? 7u to the 6th times u prime. So now, all you gotta do is figure out what u is, which you've already got. But you gotta figure out what u prime is, which is the derivative of this. So now, this is why this one is meaty. You've got a blank rule inside of a blank rule. This is gonna require what rule? Quotient. And it's inside of a power rule. Okay? So I would call this F, maybe this G, and write my quotient rule out and do that, okay? So once you find U, you know U, once you find U prime, you sub in. So take a second to finish that problem, and then we'll go from there. Okay, so just again, this is for you guys as references as you're working your problem. We're filming these so that you have something to watch and kind of help you out. So I'm going to go ahead and do the solution to this while the people here in class are working it. So I already know what U is. That substitution will go here. I have to find the derivative of this U, which I now am setting this up as a quotient rule. So it's F prime G minus G prime F over G squared. So my F prime is 3t squared. My G prime is 5t to the fourth. And those substitutions will go in here. Let's see, 3t squared times G, which is t to the fifth minus 1, minus G prime 5t to the fourth times F, which is t cubed, all over G squared, which is t to the fifth minus 1 quantity squared. And when I, make sure I'm not losing my, yeah, sorry, it's a t cubed here. It's going out of the screen a little bit. So now if I distribute this, I get 3t to the, what's t squared times t to the fifth? What do you do with your exponents? Add t to the seventh minus 3t squared minus 5t to the seventh. So then I'll be able to combine these two over t to the fifth minus 1 squared. So 3 to the t to the seventh minus 5 to the seventh. So we can write this as negative 2t to the seventh minus 3t squared all over t to the fifth minus 1 quantity squared. And that, all of that goes in for u prime. This is my u, it goes in there. And now it's just about rewriting it, the answer. So y prime equals 7 t cubed over t to the fifth minus 1 all to the sixth times u prime, which is negative 2t to the seventh minus 3t squared all over t to the fifth minus 1 quantity squared. That was that's the derivative of the inside, okay? And this is your answer in the box here with the asterisk. All right, not pretty. You can see the difficulty that arises with these chain rule problems. On every problem, the first question I ask myself, what's the big picture? Product rule. On this one, what's the big picture? The overall, it's something to the fifth. So I see that it's something to the fifth, so I know it's a power rule. On this one, what was the big picture? It was something to the seventh, so I know it's a power rule. And then I wrote out a formula for my derivative so that I could then attack the problem. And that is a little help here as you're working these problems. Go ahead and stop this and we'll get this video sent to you.